Let's look at the derivatives of inverse trigonometric functions such as sine of x or inverse sine inverse of x, which is also pronounced as arc sine of x. But the inverse of sine is but before we start doing that, I want to do some quick trigonometry. That is, we need to figure out what this value is. The cosine of sine inverse of x. What is that? We need to figure that out in geometry or trigonometry real quick. So let's say you have an angle, okay, which is theta, and then sine of theta is equal to x. All right, sine theta equal to x, which means sine inverse of x equals to theta, where x is this value, and here's 1. All right, so sine is opposite divided by hypotenuse. So then sine theta equals to x over 1, which is x, and sine inverse of x is just your theta back again. Now, what if we figure out sine inverse of x, cosine of sine inverse of x? In other words, what is cosine theta? Cosine theta equals to, well, to do that, you do the Pythagoras theorem, right? What is this side? Cosine is adjacent over hypotenuse. Hypotenuse is 1, but what is adjacent? By the Pythagoras theorem, it is the square root of 1 minus x squared. And therefore, that's cosine theta. Therefore, the cosine of sine inverse of x, we said before, is equal to square root of 1 minus x squared. That's a cute little thing from trigonometry that you may or may not have done. Doesn't matter. We're doing it now. Now, having known that, now let's do example 6.43. We have g of x equals to sine inverse of x. I'm just going to call it that instead of arc sine, because arc sine sounds, I don't know, weird, but it means the same thing. So sine inverse of x, how are we going to find the derivative? To find the derivative, we go for the g prime of x. Go by the formula that we've been looking at so far. What is the formula? The formula says, well, I'll write down the formula here. G prime of x is equal to 1 over f prime of g of x. This formula is from a couple of pages ago, right? And so we'll apply that. So then that equals to 1 over wait a second. Now, before we get there, we need to figure out now what was f of x? I should define that first. So where f of x, okay, where we have f of x, give me a second. Now, f of x, I forgot to mention, is the original function, the inverse of g of x. F of x is sine of x. I should have mentioned that earlier. Okay, so we know what we're talking about. So that I know what f prime is. So following this formula to calculate g prime, then we have g prime of x equals to 1 over f prime, apply the chain rule. F prime is cosine, right? F is sine, so f prime is cosine of something, a bunch of stuff. Then multiply by what's inside. So what's inside is g of x, and then multiply g prime of x. What? Give me a second. What? Okay, g prime of x is 1 over f prime g of x. Well, being the f is sine x, then f prime g of x is just simply cosine g of x. I was making too big a deal out of it. Okay, now which is equal to cosine of g of x is sine inverse of x, sine inverse of x. And what is that? That is ultimately cosine of sine inverse of x, as we have shown earlier, is equal to 1 over, is equal to square root of 1 minus x squared. So this will be, we'll copy that down. That will be equal to square root of 1 minus x squared. Okay, now that is the derivative of sine inverse of x. You end up with some kind of square root as a fraction. Now let's turn to the next page. And the page after that, you have the derivatives of theorem 3.13. This is on page 304. Though you have the derivative, not just sine, but all kinds of good stuff. Okay, that is, I don't think it's necessary to memorize these things. The inverse of sine is used not that often, I don't think. So, but it's good to know. And for this section, then you're gonna do the homework, and the homework is you will apply these things, and probably together with the chain rule to crank out all kinds of stuff. And they are all pretty straightforward, so I will assign them as homework. But maybe I should do one of them. Let's see, where is it? Okay, let's do one of them. Example 3.65. 3.65. You have f of x equals to tangent inverse of x squared. All right, so how do you do that? Well, you just look up the theorem formulas where it says the derivative of tangent. It goes to, where is it? Okay, the derivative of the tangent inverse of x is equal to, I will write it down here, is 1 over 1 plus x squared. Now, your book have the x in parentheses. That's probably not necessary. It's just 1 plus x squared. It's just how it works out. All right. Now, you apply that rule to our function here. Here's what we're trying to take the derivative of directly with the chain rule. And you get f prime of x equals to derivative of tangent is that thing. Okay. So let's copy that down. It's 1 plus x squared, whereas x is there's a chain rule happening. This isn't just x in here, it's actually x squared. So you have to write down x squared, and then you have to multiply by the derivative of this thing, which is 2x. All right, maybe that's why your book has the x in parentheses, so that you can see better. You have to plug the x squared into the x to have the chain rule come out. So so by the time you simplify this slightly, this happened to be fairly easy to simplify, and that equals to 2x over 1 plus x to the power 4th, which is what the right answer is. And that's that. So for the rest of the problems, for the rest of the examples in the book, such as you're probably calculating some velocity or some other tangent line or something. Nope, that's about it. There are 2 more examples, 3.66, 3.67. Please do them as homework. And also for homework, please do page 306, problems 261, 265C, 267C, 269, 271, 73, 75, 79, 83, 85, 89, and 93.